Hello, my name is Elise and I'm here to demonstrate my assignment 3. The program I made over here is inspired by the paper Floating Bubbles, which proposed a program that exposes the adjacency relationship between spaces. There are two main rules in this mechanism. Based on the relationship matrix, the two bubbles that need to be adjacent will have to move towards each other and eventually be next to each other. And the second rule is no bubbles can overlap with one another. And if they do, there needs to be a separation force that kind of separate them in different directions. So my script over here is organized in 3 parts. The generator is the main component which runs that simulation. The adjacency matrix right now is randomly generated. It is represented in a 2D list of positive ones and negative ones. And over here, these sliders can be controlled by users to determine how many bubbles and the minimum and maximum radius. And lastly, over here is the visualizations of the index and the bubbles themselves. So let me go ahead and demonstrate. Right now we have 4 bubbles on the screen and they're labeled by their index. Once we change the toggle to false, you'll see these lines that indicate their adjacency relationship. So the ones that are connected means they have to be next to each other. And our program was able to find a solution that achieves all of the adjacency requirements. So 2 and 3 need to be next to each other, 1 and 3 need to be next to each other, and 0 and 1 need to be next to each other. So that's essentially the fundamental mechanism. And I can try changing the number of bubbles over here. So for instance, if we increase it to 5, and we can see if the program can find an ideal solution for us. And it does. So it's interesting to note that there is a global goal and each individual agent is also moving independently to achieve that goal. So like what we saw, the 4 had to come through and overlap 3 for a second and then essentially squeeze in here in the center. And that concludes my presentation. Thank you very much.